In this video, we will see how to do a PCB design for AC to DC converter or um, a mobile charger or 5 volt regulated output, DC output. So in this circuit, I'm going to open the schematic first. Before starting the PCB design, we need to have an idea how this output should be like, or what is your fabrication. After fabrication, how you are going to connect with the external world. So in this video, I'm going to consider the step down transformer is outside of the PCB. Like, I'm going to take the secondary side of the transformer output will be connected to a connector or a screw terminal into the board. So in this PCB board, we will have a screw terminal at input side and output side. Only we are going to focus on the converter part in this PCB. So we need to take the components as per this configuration. So I'm going to take screw terminal. So in this schematic circuit app, we need to select the components what we need to what have in the circuit. So just click on this add symbol. You can see the third option here. Op amp type of symbol is here. Otherwise, the shortcut is you can press letter A in the keypad. You will get that component list. So first time while opening this choose symbol, it will take some time to load or to install the symbols. Because I already opened it immediately, I saw this window, but for first time it will take some time. Don't get confused with that. And here you can able to get the component whatever we need. By default, few components are there in the KiCad. Suppose if symbols are not available, or what you want to connect in the circuit, if the component is not available in the KiCad, you can download and import the symbol footprint as well as 3D model. One more video I will make how to import the symbol and footprint into the KiCad later. I'll give the link in the description. Now first point is I'm going to import the screw terminal. So you can type screw. So in screw terminal we have a lot of options, but I'm going to take two screw terminal 1 into 2 because it is sufficient for me to take phase and neutral of secondary side of the transformer. So you can choose this screw terminal 1 cross 2. After choosing this, here you can see my mouse pointer. The symbol is uh, in the top part of this choose symbol. You can see the symbol of the screw terminal 1 cross 2. Like that, we have many screw terminals, right? But right now I need only 1 cross 2. After selecting the symbol, I want to select the footprint also. So after that, you need to click the drop down below this symbol, schematic symbol. You have a drop down here. Here you can find your appropriate footprint for your screw terminal. Right. So I'm going to search my screw terminal. Usually I will go for this Ponics 1 cross 2 horizontal. If it is not suitable or if it is not okay with you, you can come back and again change your footprint. It is okay, because we cannot memorize every footprints, because there are more footprints are there, right? So you can choose. Initially I'm going to choose this horizontal. Let's see how the terminal is. I think this is good for me. The yellow color is nothing but the soldering mask which will be there. By seeing this soldering marks itself, you can understand whether it is a through hole or assembly. Through hole will have this yellow color type of solder mask, Whereas if you see SMDs, I think in two screw terminal there is no SMD. I will show SMD in next another component. So I think this is good for me to select this footprint and then click OK. And then after click this, you can see my mouse is following this. I mean the symbol is following my mouse, so it means that I need to place it somewhere in this canvas or working area of the schematic. So I'm going to place this here, right? And still you can see my mouse pointer. See, you can see my mouse pointer. Some op amp symbol is following in my mouse pointer. It means that, but means that still my still I have selected this component mode only. So we need to press escape if you want to do some other operation, or if you want to still continue to add the component to the circuit, you can still have the same. And if you click with this symbol, you can see that again it's going to the searching of the symbol. So you can what erase it if you don't want this by, or you can remove this component selection option by just pressing the escape. It will move, or it will remove. And I need one more screw terminal at the output side, so I'm going to take one more screwdriver, screw terminal. The problem is here, suppose if you copy and paste the same thing in second time, it will not take the what footprint, or if it will not select the footprint, only symbol will be copied. So best practice is always go to the symbol selection and then take one more time this one, because it by selecting the component one more time from the choose symbol, it will enable the, or it will merge this symbol again, I mean to your symbol, merge this footprint to your symbol. And I'm going to just rotate this by pressing button R, keypad R, and I keep here, and then I'm pressing escape to remove this component selection option from my mouse. And you can see this the symbol name is here is J1, and the name of the symbol is screw terminal 1 cross 2. Here it is J2, and again the name of the symbol is screw terminal itself. Right now I want to take the bridge rectifier, or you can take some normal diode itself and make a bridge. But I want to select this bridge rectifier configuration using some IC. So let's see. I already selected some IC, a bridge rectifier. In that DB170 is a bridge rectifier where we can take it directly to the circuit, and it can give the supply a rectifier output up to 1 amp load. We can connect with this IC. So I'm going to choose this IC for my bridge rectifier application. So let take the name of the IC is DB107. So I'm going to search that DB107 in the component. So I'm going to type DB107 here, and you can see after clicking this, there is a symbol as well as um, footprint is available for this DB107. So we can take this. Suppose if you not find this symbol in your software, you can see my one more video. In that I have explained you how to import this what import a symbol and footprint and 3D module from external from other platform to this KiCad. Okay, click OK this, and then I got this symbol here, and I need a capacitor, so I'm going to use the electrolytic capacitor. So again, click the component and then search for the capacitor. So in this capacitor, I choose this polarized capacitor because I need to use the electrolytic capacitor, and then you choose the footprint, what type of capacitor you need. So you can see in this drop down of this footprint, there are few SMD. In this SMD, you can see the footprint is in a red color. It shows that the copper on the top. So it is SMD. We don't want SMD. We need through holes because we are going to only focus on the through hole. And here I'm going to use, I can see few more drop downs, and then after all this SMD is over, we can see a capacitor with through hole. And I will take the first option from the through hole. I'm going to select this through hole, that is 10 mm length and 4.5 mm diameter, and then 15 mm P. I'm going to select this, but you can see this capacitor is not in the horizontal that we will usually keep the capacitor. I'm going to change and see whether the other model, radial model, yeah, this one is fine. So the radial model usually we'll put it is we will take the capacitor in the radial model. So we'll take the radial model with at least 6 mm diameter, and then click OK, and keep it for the input side, and as well as the output side we need one more. So I'm going to take one more capacitor, and already it is selected, so I'm going to just click OK, and then paste this in the output side. So just I'm planning, there will be a screw terminal in the input side where the voltage from step down side of the transformer is fed here, and then before rectification I'm going to filter this, and after rectification I'm going to filter again, and then I'm going to give it to the screw terminal. So this is what the plan is, and we will take a voltage rectifier circuit. So I'm going to take 7805 voltage regulator we will take, and then I'll choose through hole horizontal. So this looks fine. So vertical I have chosen, and then click OK. So I'll keep here, and then this is for the input capacitor, and then this is for the output capacitor, and then this is output terminal. So that's it. So we got all the component what we need for this circuit. Just we are going to connect this, and always I will keep the one for phase and two for neutral if this is AC, and one for VCC and two for ground if it is DC. So you can have your own way of connecting it. Until otherwise, if you are confident that your connections are proper, you can have a clear idea. Right, I'm going to just connect the components, and then so this one is the primary side of the transformer is going to give in the pin number 3, and then this 4 pin can be connected in the neutral of this transformer, which is going to be connected in the terminal 2 of the screw terminal 1, and then this plus I'm going to connect in the input side of LM7805. This is the voltage regulator. The output of this voltage regulator will give 5 volt always. Then I'm going to connect this negative to terminal 2, and then this 1 to the output, and this capacitor, input capacitor, I'm going to connect this to here, and then this to here, and here to here. So that's it. Our circuit is done. Here you can see circuit is done for a normal bridge rectifier, very small circuit. We have one bridge rectifier which is DB107, and we have two uh, screw terminals, and the first one is connected to the will be connected to this secondary side of the transformer, and then screw terminal 2 is going to connect at the output side. So at junction screw terminal 2, we will get the output 5 volt always, because we have connected the voltage regulator. So we'll get the 5 volt, always 5 volt at the junction 2. This is the plan. So we are going to make this circuit. So once the schematic is done, then we can go for the PCB designing. So for that, you need to click on this tool and then press this update PCB for the schematic, or the shortcut is function pin A or F8. Function pin 8 F8. And it will take some time to configure your schematic into the PCB mode, and it will direct us to the PCB, and it will show if some error, something is missing. It will show the error here. So we got two errors. Let me try to rectify the errors later. And then if now for time being, you update the PCB and then close it. And if you see, after completing this, in my mouse pointer is carried, or when I change the mouse pointer, the components which I have taken from the schematic is carried out. So you can place it somewhere. So I'm going to just place it here for the time being. And then if you zoom in, and if you see, we got the components, right? So we got the component here, and we check what is the error we are getting. So once again, I'm going to click on this tool and then update. So the error is from C2 and J2. No footprint is assigned. Let me check what is that error. Go to this schematic, and then this is C2. So this C2 and J2, C2 and J2 is not assigned the footprint. So let me check this. So click on this C2. Click on this C2. Then you can see if initially we assigned the footprint directly from selection of the component, but here, because it is not assigned properly, so we need to assign it again. So click this after double click, go to this footprint, and then click this 3 lines browse button, where we can select the footprints for our needed. So I'm going to check again capacitor, capacitor, electrolyte, SMDs are there. I'm going to take electrolyte SMD. We need trim type of capacitor. CP radial, we will take at least 6 centimeters. So now we got the footprint. CP radial, dimension 6.3, and P 2.50. This is purely based on what type of capacitor you're going to use. Based on your size and things, you can always refer your data sheet, what is the diameter, and then size, strip size, everything you can check it from the data sheet, and based on the size you can select what type of capacitor or resistor you need, and its respective footprints. Then click OK. So now footprint is assigned for C2. Let's check once again what is the problem, in any errors we are getting, and go to tool and update the PCB. You can see the error for capacitor is removed, and only error for the J2 is present. And click on the update PCB and then close. And after completing the assigning the footprint, you can see my mouse pointer is carried out only the capacitor, because the footprint is assigned just now. So after completing or updating our PCB to the schematic, from schematic to PCB, this capacitor alone coming with my mouse pointer. So you can place it somewhere here, and then let me check for the junction 2 also, that is 2 screw terminal. Double click it again and go to the footprint and choose the footprint what we need for this junction. So to avoid this error, we need to second time what happened is, when I choose the component, I have assumed that the footprint is visible, so it is selected, but it is not actually selected even though the footprint is visible. So what we need to do is, we need to click on the footprint in the drop down also in the initial stage of selecting the component. So again here I'm going to type screw terminal. So screw terminal, we need two, right? So I'm choosing the first option, terminal block. You can see the 2-pin terminal, pitch 5.0 mm. So this is okay for me. So I'm just going to click this and click OK. So now footprint for the terminal 2 is also assigned, and then I'm going to just click the OK. Let's check the errors. So there is no error, and you can see this, the mouse pointer is carry out the footprint of this one. And you can see the terminal 2 footprint I have chosen different, and terminal 1 is different. So it is appropriate to take what type of footprint you need. And you can see this, there is no big difference in actual holes. By seeing this, the holes are okay, but still the outer layer and the size are maybe differ. But as long as you get two holes to connect your terminal, it is okay. But if you need a proper design or proper way of connecting the terminal, refer your data sheet, and based on your data sheet we need to choose our terminal. So J1 is the input and J2 is output in this case. And now next immediate thing is, we need to uh, arrange the board, arrange the circuit as compact as possible to see our to exactly get the PCB board as compact as possible, because the size of PCB is directly proportional to the cost also. So if you have a bigger size of PCB, then cost is also going to be higher, production cost will be higher. So always even customers need the smaller size instead of bigger one. So we always try to minimize the size. And so because to minimize the size, we need to have a clear idea about how we are going to design this. So just we have a 3D view in this moment. I not connected anything, so you can see in this 3D junction 2 I don't have 3D because I have chosen the footprint later, but in junction 1 I have the 3D printer. Okay, so what I'm going to do is, I'm going to delete this J2, and then I'm going to again take the J2 to the schematic. Let's check how I'm doing that. So go to the schematic and then just delete this because I don't want this. I'm going to add junction 2 from the actual footprint itself. So type screw terminal 1 cross 2 and then select the appropriate. So I'm going to take this phonics 1.2 horizontal with 5.8 mm, right? So click OK and then connect this. So the ground I'm going to connect with, this wire, and then and then this is for the VCC. So it is connected. Again, go to this update schematic and then update this. I'm going to delete this. Again, go to PCB and update this. So after updating, I got the new screw terminal which is added recently. So just click that. Now you can see 3D view. So I got, yeah, again you can see this, the size from one to another is different because this is 5.8 and this is 5. So uh, it's okay for just for the simulation sake, but if you are taking the actual circuit, we need to take the data sheet, and then based on the data sheet you need to select what type of component you are going to take. Even though the symbol is okay, but the footprint is matters more, so you need to take appropriate what components. But if you are okay with this, and in actually you are taking what you are going to buy the screw terminal in the equal size, this 3D model is not that much important until otherwise the size of this lids are fixing together. Okay, let we start to do the tracking part. So I'm going to close this 3D view for now, and then let me try to connect this. If you see, actually the screw is this side, so we need to keep this screw outside of the PCB. So I'm going to turn my terminal like this so that you can see the 3D view. It is turned like this so that the customer can screw their wire, they can fix the wire in that. So this corner is I'm taken so as an input, and then I'm going to take this is same way. I'm going to take this side, let's check, but it is in the reverse side, right? So it is, I am expecting the screw or the wire should be inserted this side, so I'm going to turn it again of 180 degree. So let's check. Yeah, now it is fine. So wire, customer can put wire here and then they will tight the screw here, so it looks fine, right? And then yeah, let me take the bridge rectifier. See, there are some mild blue color line is given. It shows us the how the connection based on our schematic. So always make sure that you don't have more twisting in the track. So I'm going to I'm trying to minimize the twisting like this. Fine. And then this is the voltage regulator I'm going to keep here. And this is the output capacitor, and this is the input capacitor. And this is the outer screw terminal. Let me rotate this to minimize the twisting. Let me remove all this silk screen, and then let me check. I don't want to see these names and other things, so I'm going to just remove the silk screen, and then we can check this. You can see, so this line is going in the top, so, and this one is connector here. So try to rotate this, but if I rotate this again, there is a twist, so I'll take it back to the original position like this, and then let it be. So what we can do is we can bring this down so that it will eliminate all the problem. Okay, so this is how we need to make a decision to minimize the size or to make as simple as possible. So if we reduce or if we are okay or if we try to minimize the twisting here while placing the component, it will eliminate or it will make easier to the connection, right? So after placing this, then we can go for the outer cut. Outer cut is nothing but how we need to cut the PCB or the size of the PCB, right? So for that, you select this edge cut. You can see my mouse pointer. So there is edge cut here, right? You can select that edge cut and then click on this rectangle, draw rectangle. After that, just go to any one corner that you want to make the circuit and click there and then just drag it till how much you need. So while dragging, you can see the size of the board in X and Y axis. That is, in X it is 65.96 mm and in Y it is 20 mm. That is nothing but 6 centimeter to 2 centimeter size. So that's that much compact we can make this circuit, right? So I'll try to make it 66 and 21. Okay, nearly 21 I'm getting. So I'll fix this. Yeah, now you can see, go to view and then go to 3D view. You can see this is the board I'm looking for. For this bridge rectifier, that is not 3D model because that components I have imported from third party. So but still the footprints are proper. If you buy in the local store and you can fix it in the board, so it will work fine, right? So let me start the routing part. I'm going to make this as a single layer, so I want the lines to be in the back side of the board. So I'm going to take the track in the back copper. So click this second option, that is the blue one. I can zoom and show you. This is the second. This is the front copper. This is the back copper. So I'm going to select this back copper. I'm going to select the route track. So click this. First, you select the back copper and then select this routing. And then yeah, zoom it by scrolling your mouse wheel. So I recommend you to use mouse even though if you're using the laptop, because mouse will make you the connection easier, because many times we need to zoom in and zoom out, so better to use the mouse and then the scrolls because it is needed. So I have selected, as I said, I have selected the back upper and then track, and just go to the line where you need to connect. So this lines, the blue mild blue lines will guide you how to connect route the PCB, and just drag and drop this. So once I click here, it will highlight where should be the next connection based on our schematic. So the immediate one, always I will click here, I will connect here, and then from here it is this, and then from here it is this, and then from here to this, and then from here to this to this. Okay, but I feel the ground should be connected in the ground, but let's check the connection. If the connection is wrong, again we can revisit. Yes, I missed here. You can see I missed the ground should be grounded here. That part is missed, so I'm going to connect that. And then so make sure that the circuit is proper. Otherwise, the schematic will not show your connections, because this KiCad is not the actual simulator is just follow what we have connected. So make sure that you have a appropriate circuit with you and then connect based on that. So now I'm going to update this and then close. See, after updating, I can see one more line is added in this ground. So yeah, now we will connect this again, select this routing and then connect this. You can connect either here or here, anywhere is okay, but I'm going to connect here. Okay, fine. So now the connection is done and yeah, so this is very simple circuit I have connected. Let's see the 3D view of this. So in top side there is no any tracks, and in the bottom side you can see the tracks, right? So this is how the circuit is done. So now our normal bridge rectifier is ready. Okay, in upcoming videos we will see how to add some silk screen, add your name, some meaningful names like ground, VCC, those things we will see in next video. This video is just to understand the basic working of PCB KiCad design. PCB design using KiCad, right? So important things is we have three area. One is schematic. In that schematic, you need to choose your component for your circuit and you need to connect the circuit properly, and you need to choose appropriate footprints for each and every component. Once it is done, and make sure that the routing is proper, and placement of the routing is also important to reduce the size. And finally you can go and check your 3D. Last but not the least, there is a design rule check. We need to confirm our what the connections are proper. So for that you can go and check your design and click this design rule check and then run DRC, and we got zero error and zero warning. But if the circuit is going more complicated and complicated, we may miss some part like the gap between two tracks and then overlapping, and those errors can be brought it out to our knowledge from this design rule check. Okay, so it is very important to make this design rule check and then close it. And finally we need to send this to the factory, right? So without sending to the factory we cannot fabricate this. So factory need a few files like front copper, back copper, drill, and all other, silk screen, right? Outer cut layer. Okay, all these things can be made in one click by just click on the file and then go to fabrication output and click on this Gerber, and then before generating the Gerber you can generate the drill files. So click on this drill files. Here you can choose what are the files need to be sent to the factory. So like uh, this is the front copper, back copper, and uh, I don't want all these things. I want very important things like silk screen, back silk screen, front mask and back mask, edge cut. These are all the very important things. I'm going to send all these things to the fabrication. So for that, I need to plot the Gerber file, right? So before that, we can choose where the Gerber file need to be stored. So as I already opened a new folder called charging circuit, which is shown in the first video of this series. Here I'm going to choose a folder called Gerber. So I'm going to select this folder to generate the Gerber file here. Do you want to use this path? Yes. Can click this, yes, and then generate the drill file first, and then generate the drill files, and then close it, and then plot. So once plot is done, you can see the Gerber file. These are all the Gerber file generated, like copper, back copper, silk screen, edge cut, all these things are the fabrication files that we can send to the uh, PCB fabrication unit just by making this to the zip file. So we need to add it to the zip. So this zip file we can send to any of your PCB fabrication unit. They will make the PCB what you have designed, and then they will send the PCB to you. So finally PCB, the fabricated PCB will look like this. And in the fabrication they will not assemble the component until you ask for it. By default they will give only the board. Some PCB fabricator, they can do the assemble service also. For that they will charge extra cost. Otherwise you can buy and do soldering by yourself. Right, so that's all from the first video. Thanks for watching this video, and please follow my YouTube channel, subscribe my channel to get uh, other technical tutorial videos timely. Thanks.